Our Eggstronaut is ready for its next adventure. However, before takeoff, it still needs a way to safely land on a new planet. How can we solve this problem? We can use the engineering design process to design and build products, like building an egg drop lander to help protect our Eggstronaut. The engineering design process has several steps. Let's look at each step as we design and build an egg drop lander for our Eggstronaut. The first step is to define the problem that needs to be solved. A good way to define a problem is to answer the following questions. What is the problem? Who has the problem? And why is the problem important to solve? For our egg drop lander project, the problem statement might be, our Eggstronaut needs an egg drop lander that protects it from the impact forces of a fall because it wants to land safely and in one piece. Now that we know exactly what problem we need to solve, we can move on to step 2, which is doing background research. In this step, we want to find out as much as possible about our problem and learn from the experiences of others. When doing background research, we can find information in many different places. We can use books in the library, search the internet, or ask an expert or specialist questions about the problem we are trying to solve. Learning more about the problem often sparks initial ideas for how to solve it. To get ideas for our egg drop lander, let's find out how things are usually protected from breaking. After doing some research, we find 3 common solutions used by others that may be helpful in designing our solution. First, we find that packaging materials like foam, bubble wrap, or packing peanuts protect objects during shipment by absorbing energy from bumps and drops that could otherwise cause an object to break. Similarly, we find that car bumpers are designed to crumple in order to absorb some of the energy from a head-on car collision. This helps keep the people inside the car safer. We also find that parachutes are used to slow down people, spacecraft, and cargo to help them land with less force. This is all useful information that we can use when designing our egg drop lander. The next step is to specify the requirements for our design. To do that, we need to think about what criteria our design must meet in order to be successful. Such design criteria might include specific physical features such as weight or size, cost, material availability, specific functions such as being reusable, environmental impact, and many more. What are some criteria that our egg drop lander needs to meet? It needs to be lightweight or weigh less than 100 grams. It needs to be smaller than 20 centimeters in length, width, and height. It needs to be made from inexpensive materials. It needs to protect our Eggstronaut from breaking when falling from 8 feet. And the Eggstronaut needs to be able to get in and out of the lander in less than 1 minute. With these design criteria and the information from our background research in mind, we can now start step 4, brainstorming and evaluating possible solutions for our problem. At this point, we want to come up with as many solutions as possible, even wild and crazy ones that may not work. This step often includes examining existing solutions, brainstorming new ideas, and making sketches of possible designs. How could we design our egg drop lander? Some ideas are we could use straws to build lots of bumpers that create a crumple zone around our Eggstronaut. We could create a box with lots of foam, cotton balls, or bubble wrap cushioning that protects our Eggstronaut. We could build a parachute that slows down our Eggstronaut's fall. Or we could use a jetpack with thrusters to gently land our Eggstronaut on the ground. These are all good ideas. How do we choose which solution to try? First, we eliminate any that do not fit the design criteria we identified in step 3 of the engineering design process. Then, we evaluate the designs that are left. To help you evaluate your designs, you might try these strategies. Make a pros and cons list for each design. Figure out which design meets the most design criteria. Compare how long it would take to build each design, and determine how much each design will cost to build. During this process, it may be obvious which solution to try first. Or, it may make sense to combine several solutions to make an even better solution. For example, to build the best possible egg drop lander, we could combine 2 of our ideas from brainstorming and make a box with both cushioning to protect the Eggstronaut and a parachute to slow down the box's fall. Once a solution has been selected, it is time to start developing and prototyping the chosen design. Making a prototype means making a working model of our solution. This is a key step in the development of a final solution. To build our prototype egg drop lander, we will take the box that holds our Eggstronaut, add some cushioning, and then attach a parachute. The next step is to test the prototype. Testing allows us to find out if our solution works and how well the prototype meets all of the design criteria. Testing almost always involves collecting data about the product's performance. It might also include getting feedback from others. Sometimes test data will show that the solution does not meet all of the criteria yet. That is okay. If that happens, the project is not over. Instead, a loop starts that includes making changes to the design or trying a new design, testing the new solution, finding more problems, and improving the design again. This process is called iteration. It is common to go through multiple iterations and redesigns before arriving at a final solution that meets all the design criteria. How successful is our egg drop lander prototype? To find out, we need to check all the design criteria we listed earlier. We measure the weight and the size of the prototype. We test how long it takes for the Eggstronaut to get in and out of the lander. And most importantly, we need to test if the egg drop lander protects our Eggstronaut from breaking when dropped from 8 feet. Oops, it looks like our solution doesn't work. Based on the results of our test, we need to iterate and go back to our design idea to see how it can be improved. Maybe we can add cushioning materials or bumpers on the outside of the box, or maybe we can make our parachute bigger. There are many changes we might make to improve our egg drop lander. In the end, a design solution is successful if it meets all the design requirements and solves the original problem we identified. It may take several iterations to make the best possible egg drop lander, but each new iteration helps us learn what changes we still need to make or what problems we still need to solve. Let's see if the changes we made to our egg drop lander prototype help our Eggstronaut land safely. Yes, we did it! We found a successful design solution for our Eggstronaut's egg drop lander. One last step remains in the engineering design process. Now that we have made a successful egg drop lander, we need to communicate our results. This means communicating all of our findings and design solutions in a written report, oral presentation, or in some other way, so that anybody who needs an egg drop lander can use our information to build their own. Now our Eggstronaut can start its next adventure without needing to be scared of a fall.